Hi, I am Arib. You are watching my YouTube channel. HVAC versus HVDC. High voltage direct current, HVDC, power transmission systems, also known as power highways or electric highways, use direct current, DC, to transmit power versus the more common alternating current, AC, systems. Most HVDC power transmission lines use voltages between 100 kV and 800 kV. In comparison with AC transmission systems, high voltage direct current (HVDC) transmission has many advantages due to its long transmission distance, large transmission capacity, and easy power regulation, and is widely used in long-distance power transmission, asynchronous networking, island power supply, and other fields. At present, the main protection schemes for DC transmission lines include traveling wave protection, differential under voltage protection, DC differential protection, etc. HVDC allows power transmission between asynchronous AC transmission systems, as the power flow through the HVDC link can be controlled independently of the phase angle between source and load. HVDC also allows the transmission of power between grid systems operating at different frequencies, example, 50 Hz and 60 Hz. Allowing power to be exchanged between incompatible networks improves the stability and economy of each grid. HVDC and HVAC are the two most important power transmission methods today, and the differences are analyzed in terms of technical limitations, technical comparisons, and economic benefits. For AC transmission, the biggest advantage of overhead lines is the ability to bundle multiple conductors. If the overhead lines in the table are 2 conductors per phase, the rated power per system can also reach the power per system of 500 kV for underground cables. For DC cable transmission, plus or minus 500 kV transmission can be achieved if mass-impregnated cable, viscous impregnated cable, is used. Overhead line transmission can reach a power rating of 7,200 megawatts, 8 conductors per pole, when using plus or minus 800 kV transmission. But with the development of technology, voltage levels have been able to reach plus or minus 1100 kV, LCCH-VDC. China is now under construction with a total length of 3,324 kilometers of ultra-high voltage DC transmission is the use of plus or minus 1100 kV voltage level. But for VSCH-VDC, because it is limited by the IGBT voltage level and output power, the voltage level and power compared to LCCH-VDC will be much lower. Here to point out is for AC submarine transmission line, the current technology cannot transmit voltage higher than 275 kV, the power per phase higher than 400 MVA power. There may be progress. So for offshore power transmission, HVDC transmission is the only choice. Overhead lines cannot be used in offshore situations. High voltage alternating current, HVAC, in a transmission line refers to the use of an electrical potential greater than 1000 volts, according to the International Electrotechnical Commission standard, to transmit electrical energy over long distances efficiently. The current in the line periodically changes direction, which is a characteristic of alternating current. This is the standard form of electricity used in power grids. The primary advantage of AC is that its voltage can be easily stepped up or stepped down using transformers. This is crucial for efficient transmission and safe distribution. Voltages in transmission lines are significantly higher than household levels, which are typically 100 to 240 volts. Common transmission voltages range from 110 kV up to 765 kV or more, with extra high voltage, EHV, classified as 345 kV and above. These are conductors designed to carry large amounts of electrical power from a generating station, often far from population centers, to substations near consumers with minimal loss. Purpose in transmission. The main reason for using high voltage in AC transmission lines is to minimize power loss. HVDC transmission has the following main advantages over high voltage AC transmission. When the power delivered is the same, DC lines are cheaper. Three-phase AC power requires 3 wires to transmit, each wire to ground insulation in accordance with its peak design. DC power requires only 2 wires, only one if it is unipolar, and the peak value of DC power is equal to the RMS value. Therefore, DC transmission can save a lot of transmission materials and also reduce a lot of transportation and installation costs. Secondly, DC transmission has a simpler structure of overhead line towers, narrow line corridors, and cables with the same insulation level that can run at higher voltages. DC transmission of power consumption is small because DC overhead lines use only 1 or 2 wires, so the active loss is small and has a space charge effect. Its corona loss and radio interference are smaller than the AC overhead lines suitable for submarine power transmission. General AC power transmission is mostly overhead, the line and the formation of a capacitance of the earth, but because the composition of the air capacitance is very small, so the impact on the circuit transmission is very small. But for underground cables and submarine cables, because the cable and the land between the sea will form a larger capacitance, so the capacitive resistance is smaller than the high-altitude erection, equivalent to the formation of additional branches, which in turn causes additional line loss. The problem of reactive angle stability. In the AC transmission system, all synchronous generators connected to the power system must be kept in synchronous operation. If a DC line is used to connect to AC systems, the above stability problem does not exist because there is no reactance in the DC line. That means DC transmission is not limited by the transmission distance. Can limit the short circuit current of the system. When connecting to AC systems with AC transmission lines, the increase in system capacity will increase the short circuit current, which may exceed the original circuit breaker blocking capacity, which requires the replacement of a large amount of equipment, increasing the amount of investment. When the DC transmission, there is no such problem. Fast regulation and reliable operation. DC transmission through the thyristor converter can easily and quickly adjust the active power and realize the tide flip. If a bipolar line is used, when one pole fails, the other pole can still be earth or water as a circuit to continue to transmit half of the power. This also increases operational reliability. A professional cable manufacturer understands and updates the latest trends in the industry. They keep up with new technological advances that may benefit their products, such as copper power cables or aluminum wires. Companies must be aware of technological advances, market trends, issues affecting global sourcing, and changes in future legislation. This means modernizing production facilities to produce quality cable products that meet international quality standards because consumers are willing to pay more. People don't like to spend extra money only to get useless cables that break down in a short time.